everyone. Welcome back again to broadcast mode. So earlier on, we have my colleague from SBS Transit Moving Thai speak about an app for our bus business. Now, I'd like to turn over to another aspect of SBS Transit business, the rail business. So a little known fact is that SBS Transit operates two of the 61 lines in Singapore, right, and also two of the LRT lines. So these are the downtown line, the blue one, the northeast line, the purple line, right, and the two LRT networks in Punggol and Sengkang. So without further ado, I'll hand it over to my colleague Mark Ng from our rail business to speak about the challenge statement, conditional monitoring of overhead cable brackets in the rail network, right? So this is very engineering heavy. Mark.
Okay, thank you, Daniel. Okay, Ken. Very good afternoon, everyone. Thank you, everyone, for coming down to join us in our room for our presentation. So I'm very pleased and honored to be here to talk about a very important issue for us. My name is Mark Javen. I'm a senior engineer in SBST Transit Downtown Line, Power Electrical Service under the Diagnostic Monitoring as well as Development section. So I represent my department today to discuss and share on a very important issue that we have faced while performing maintenance on our overhead cable bracket. So our problem statement, as you can see in the slide here, is how can we monitor the condition of the cable brackets safely, accurately, and in a cost-effective way. Just a background for Downtown Line, we have 34 stations in our line. Our trains draw traction power from our third rail, as you can see marked in yellow. So most of the third rails are actually situated away from the platform as well as the buffer area for safety reasons. And to deliver power to the trains by the third rail, we usually have about 4 or more cable brackets as shown in orange. In this case, you can see there is 4 of them. In this photo, you also can see the cable brackets marked in orange. This cable brackets is coming from our buffer area, which is connected to our TPSS room. So TPSS for us is the traction power substation, which is where you draw the DC current, DC power. So the third rails is, as you can see, is marked in yellow. And these cable trays, they are supporting our 750 volt direct current cables, which come from a buffer area and are connected to this third rail. So we usually have about 4 or 6 of them as shown in this picture here. Okay, so our current practice in our operation and maintenance requirement set by LTA, we operators are required to carry out a yearly inspection of these DC overhead cables. And our focus is actually to look at any signs of deterioration or any mechanical damages due to vibration from trains, or it could be due to ground vibration. So what we need to do is we need to check for any looseness and any corrosion which might affect the integrity of the structure. So in this photo, you can see what we do is from the start of the project, we do have this top marking, and then every year we have to go and check to see whether there's any misalignment. So if there's any misalignment, we will need to do rectification work. Maybe we need to tighten it so as to ensure that the cable brackets are in good health. So our maintenance work, we do have a 4-man team, which will set up the track trolley, as you can see in the photo. So setting up this track trolley could take about 15 to 30 minutes, depending on stations, because they have to prepare as well as to set up the trolleys. And they will use these trolleys to perform maintenance work for these cable brackets. So they will need to go up and need to check for any rust, corrosion, or any water seepage. So for limitation, first, what we encounter is we have difficulty inspecting the whole cable tray. So as you can see on the picture, not quite sure if you can see my cursor, the mouse cursor. Over here is the tracks, and usually they will set up the cable, the trolley, and they will move up the trolley, and then they will inspect this area. But as you can see on the right side, it's actually a blank area, so there's no way for cable trolleys to be at this area. So the problem is our maintenance team are having difficulty trying to inspect the bolts and condition of this side. Similarly, on the left side, there are some of we call it the cable ladders. And this site might be a little bit hard for the maintenance team to check for any corrosion or any looseness. So this is the first problem that we face. Second issue that we have is the possibility of falling. So as you can see on this picture, you can see that the height of this cable tray is about 3 meters high, or rather three times my height. So even with all the safety features in place, measures as well as the PPEs, there is still a possibility, or rather a risk of our maintenance worker falling on the track, which is what we want to eliminate. And of course, the third thing for us, our limitation is due to time. So because for us, we'll need to prepare to set up these trolleys, which we need to transport to different stations and such. And also, we also have these engineering hours, which is the time that we do maintenance work during the night. And we only allocated roughly about 3 hours or 4 hours, depending on whether we are allowed to go down to track earlier based on the traffic condition. And also we do have to plan ahead for this work. So administrative wise, probably there'll be some time delay, which is not productive and it's also not really a value added work. We would rather our technicians and technical officers to do more complex and more value added work. And because of all these factors also, we do incur this cause increase in costs incurred to perform this maintenance. So this is the cable tray that you see. So why is it very important for us? Because for us, cable trays need to ensure that the power cables are secured at all times, and it will not collapse under excessive vibration. Because in this case, if let's say if the cable do drop, it might cause an accident when the train hits the tray, and we do not wish for that to happen. And it also eliminates the risk of our maintenance workers from falling from height during the inspection, and also to improve our productivity by redirecting our manpower to do other more value-added work. And of course, this target audience is for the safety of our passengers who are taking the downtown line, as well as the maintenance team that is doing this work. So what are we looking at? We are looking at exploring and retrofitting an online monitoring system to track the health of our cable trays. And we hope to utilize IoT's internet sensors to provide data as well as an alarm when there's any issue with the cable tray, so that instead of doing one yearly maintenance, perhaps we only need to do like 2 yearly or longer, because there is always a 24 hours of monitoring of these cable brackets. And so because of this also, our staff can focus on more productive work. Thank you, everyone. This comes to the end of my slide, and we open up for Q&A.
I think maybe a quick recap on the topic statement. Monitor the condition of cable brackets safely, accurately, and cost-effectively, right?
Yes.
Obviously, this problem statement comes across as being very engineering focused, but then obviously it's a lot more than meets the eye, and I think your last slide captured that brilliantly, Mark. What Mark is looking for here is a structural health monitoring system, right, with sensors installed to provide data and alarms to assess structural integrity. So, that could involve, anything from computer vision down to audio analysis to wave and vibration, right? So there are many different ways to cut this. And I think what's interesting here is there's a hardware issue, but you're really looking for a combination of hardware and software to resolve this issue. And first question has come in, right? So let's get into it. First question from Faizan, right? Question here is, what data is available for this challenge? Categories of data even.
Okay, thanks, Faizan. So for the data for this challenge, actually, we do not have any, because what we are doing most of the time is just inspection. So we do not have any data at the moment. But what we are looking at is we do hope that there is some form of vibration, or maybe we are open to many types of data to help us to understand and to study the health of the cable trays. So it could be Like what Daniel said, it could be due to vibration, or it could be due to sound, or it could be due to photos, to understand the health of the cable trace.
Yeah, awesome, Mark. Yeah, actually, Mark, I did have a question. Would people who respond to this challenge statement, right, during the incubation phase, would they be allowed to mount sensors such as CCTV cameras or sound sensors, vibration sensors? Would they be allowed to? I assume they'll be allowed to mount it in the tunnel, right, where near the cable brackets, right? But would they be allowed to mount it, say, on trains, so that each time a train passes by, it dynamically captures data on the fly and updates it, right?
For this, okay, thanks Daniel. For this challenge, we only mainly focus on the cable trace, but we are open to installing on the trains as well. Of course, that will need to have we need to get our colleagues from the train department to understand the modification and to see whether is it a way to help us to monitor the cable structures.
Yeah, we've got another question coming from Faizan again, right, on whether you would be able to share some historical inspection reports. He doesn't mind reaching out directly to get more insight into the thinking, and he thanks you for sharing the answer.
Yes, Faizan, yes, we do have some historical inspection reports, but our inspection reports are quite simple. It's more like when you do the task, then you just have to take. So we do have some commissioning records of the installation. I hope that those reports might be helpful for you to design the monitoring system.
I have another question again in my mind, but I think there's a third question that's coming from the audience here. Right,
Okay.
so cable brackets are in the stations, or are they also between stations as well, which means in the tunnel, right? How many brackets between two stations, and what is the distance between two pairs of brackets?
Okay, Ken. So to answer the first question, the cable brackets are actually on the MRT station itself, which means there are total about four of them. So for every this is mainly the purpose is to draw power from our substation, so it's only within the station itself. And how many brackets are there between two MRT stations? So between the stations, there will not be any cable brackets. It's only at the stations. And the distance between the two pairs of bracket, it varies, depend on the design of the station. There are some stations with 6, and some of them might be a little bit further from where the original one is. Those are special stations with special requirements of a cable connection, which is why we have more than 6.
Great. How are we doing for time? Thinking.
4 more minutes. I think. Do you have for Mark?
Yeah, I don't. But I just wanted again to sound out to participants in the room who are listening in here that on the surface, this problem statement looks like a very hard engineering, hardware-focused problem statement, but it really isn't, right? If you think about it, and if you thought about what Mark said earlier on, especially his last slide, and we'll share the presentation later on for you to review. Right, do bear in mind that there are aspects of this that are IoT related, right? There's lots of sensors in play here that we want to deploy. There's also an element of it that involves visual, video, and audio analysis. So a bit of computer vision, sound and noise vibration analysis as well. So it's a combination of IoT and software that we're looking for as a solution to tackle this hardware problem. I'm not sure, Mark, if you have anything to add to that.
Yeah, I think you covered most of it. Thank you.
Great.
Thank you,
Thanks
Mark.
again, Mark.
Thank you. Thank you.